around. So it says draw circles and other figures. Today we're going to inscribe triangles in circles and draw geometric figures meeting given conditions. All right, so that means we're going to have some type of constraint. Okay, so it says Parker plans to build a circular fire pit inside a square area. He is drawing a model of paper to confirm his plans before he starts to build. How can Parker use folding paper and a compass to draw the largest possible circle fire pit in the space he has staked off? Trace Parker Square on a piece of paper and draw the circle for the fire pit. So, if you do not have a book, then you're going to draw a square that is 1.5 inches. Okay? 1.5 inches all the way around. So I want you to draw that on your paper. And I'm going to do something just a little bit different. Well, once you have that square, then I want you to draw diagonal lines from each endpoint. Okay? And if you don't have a protector, guys, then do your best at drawing the square with a ruler. All right, the reason why I had you draw diagonals is because that will tell me what the center of the square is. Okay? So then what I'm going to do with my safety compass, and you can do it with this compass too, right? Is I'm going to measure the distance. So see how the Sharpie point goes on that circle? And then your pencil is going to come real close to that line. Okay? And then you're going to use it to make that circle. Okay? So just take it and you'll go all the way around to make that circle. If you have this one, then you're going to put the clear thing right in the center, and you're going to move it to where that hole is right on top of that line. And then you just put your pencil in there. Okay? Then you're going to rotate it. So guys, I'm going to tell you, you probably need to take the paper out of the book. Okay? Hold on, there's someone at the door. Yeah. Okay, sorry. All right, so then you're supposed to draw the circle. And as you can see, it looks like my thing moved just a tad. Okay, so it should look something like that. And if it's not exact, it's okay. As you can see, mine moved a little bit on me as well, so it didn't give me that precise circle. Okay? But what you are trying to see is that we can draw a circle inside that square. Okay? So it's kind of like putting a round pizza in a square box. It's exactly what the pizza companies do. Okay, so it says, let's go back and look at the question. How can Parker use folding paper and a compass to draw the largest possible circular fire pit in the space he has staked off? Trace Parker's square in a piece of paper and draw the circle for the fire pit. which is what we did, okay? Now, if you took a piece of paper, guys, and did it, you're going to have to cut that piece of paper because a piece of paper is an 8.5 by 11. So you would need to cut it like an 8 by 8. And the reason why they say fold is because if you take a piece of paper, so here's my 8 by 8, right? And if I take that piece of paper and I fold it hot dog style and I fold it hamburger style, what happens is the creases give me the center of that square. Kind of the same thing that we just did, right? And then you can draw a bigger circle. Okay? So however you wanted to do it. It was just easier for me to draw it with the square that was there. Okay? So we know it's possible because we just did it. And I'm just going to write here C above for mine because we drew it here. All right, so the Turn and Talk says, brainstorm a list of characteristics specific to squares and circles. Okay, so what does that mean when we're talking about characteristics? Miss Capel, you can hear me, right?
Yes.
Okay, because somebody says they can't hear me. So Taylor, you... Go ahead.
I replied.
Okay, thank you. So she may need to, like, restart or something. All right, well...
Yeah.
Okay, so Hillary said, now I can just I just had to rejoin the meeting. Okay. Hillary of something. I don't know what that means. Okay, so a characteristic is something specific to that item. So if we're looking at a square, we know we have 4 equal sides. We also know we have 4 right angles. Right? So 4 equal sides, 4 right angles. We also know that the opposite sides are parallel. Okay? What do we know about a circle? Well, circle has no lines. It is also curved. In the center is the same distance center is the same distance for every point. And I'll show you what I mean by that. Okay? So the reason why, I'll come back to that in just a minute, guys. So the reason why I had to find the center is that when I take this compass, right, every point from here to here should be the same distance. And we call that the radius. So from the center to the end of the circle is called the radius. And it should be the same length if it is a circle. Okay? If it's an oval, you're going to have something different. All right, so let me go back up here. So you have the opportunity to copy it. All right, we ready to move on? All right, don't hear any no's. All right, so this is where we're going to build the understanding of what we are looking at. So it says a polygon is inscribed in a circle. If every vertex of the polygon is on the circle, to investigate the kind of triangles that can be inscribed in a circle, begin parts A and B by using a compass to draw a circle with a radius of 5 inches. 5/10 of an inch. The radius of the circle is the distance from the circle center at any point. All right, so you're going to use your compass, right? I'm just going to put a dot for the center. Now, once again, you can use this one if you want, okay, which means you need to take it to 0.5 of an inch. So if this is an inch, right, come on, focus, then 0.5 would be right there, okay, and then you would put the pointy thing here and you would draw your circle, okay. I'm going to use my safety compass because I like that better. Sorry, I had to find one that was a little bit better. All right, so we're doing 5/10 of an inch. So if you can see on mine, here's the inch, and 0.5 would be right there. Okay, and that's as furthest up as my safety compass goes. So I'm going to put my center point right on the center, and I am going to draw my circle. So guys, this is why I said this one isn't any better either, that you probably need to rip this out. Sorry, just trying to find one that's not going to slip and slide on me. All right, so there's my circle. So it says draw a circle and inscribe a triangle in it. Describe more than one. Inscribe more than one if you can. So the only constraints that we have is that every vertex on the polygon is on the circle. So I can't draw a triangle like that. That would not work because it's not touching the side of the circle. Okay? So take your ruler or your whatever straight edge you have. Okay? So I'm going to draw mine like this. So from here to here, touching, right? It's got to touch the circle. It doesn't say if it has to be acute or obtuse. So I'm going to go from here to there, and then I'm going to connect those points. Okay, so there's one. It says inscribe more than one. All right, so what if I took a triangle and went from here to here? And then I went from here to there, and then I connected them here. Okay, I could probably do another one. So I could take a triangle from here to here. Well, maybe not because that pen's not working. Let's try that again. So there's one. And I can make this one like an acute triangle, right? There's 2. And there's 3. Okay, so this one, you can have infinite amount of triangles. Because the only constraint we had was the triangle has to touch the circle. She wants to know what the correct answer was, Miss Capel. It was C. Alright, so then B says draw a circle and a diameter, which is a segment that passes through the circular center and has endpoints on the circle. Use the endpoints of the diameter and a third point on the circle to inscribe a triangle on the circle. Alright, so draw another circle. This time, it's still the same thing, right? 5/10. So put my dot. Okay, draw that circle again. All right, but this time, the line has to go through the center. And we call that the diameter. So one side of my triangle has to be the diameter. Okay? So from there, so there's one. So there's a triangle. Could I draw another one? I should be able to. If I go from here to here, and then there to there, there's another one. Of course, then I can draw all kind of ones. I can flip them on the other side. So as long as I'm touching that side, I can go from there to there. And from here to here. Okay? So you can see I can draw, once again, an infinite amount. We skipped day 4. Huh? Today's Monday. I don't know, Taylor. I don't know which one you're talking about. The one from last week should have already been uploaded. All right, so now C says draw 3 circles with a diameter of 1 inch. Can you inscribe each triangle in one of the circles? If so, draw it. If not, justify your reasoning. All right, so we're going to draw 3 circles. I'm going to draw 3 dots. So 1, 2, and 3. Okay? So it says the diameter is 1 inch. So that means, once again, the radius is 0.5 an inch. Okay? And that's what we use is the radius to draw our circles. All right, so I'm going to draw all 3 circles first. All right, so there's one. Well, this one's not going to be exact because I moved it. Come on, rotate. Sorry, I didn't like that one, so I'm going to redraw it. is why you need a pencil and not a mechanical pencil. But everybody keeps borrowing my pencils and never returning them. Okay, well, my circles are not cooperating with me. Okay, so something like that. All right, and then the third one, a little bit better. Okay, so there's my 3 circles. Hopefully we can get it to focus. Let's try that again. Focus, 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 focus. All right, so we have some constraints. In the first circle, we want to draw a triangle with a 50-degree angle. Okay? Didn't tell us anything about the sides. So I'm going to draw my first side down here. Okay? And I'm going to put a dot right here because I need that for my protractor. Okay? So with a protractor, this open circle goes on that dot, and then this line lines up with the line that I drew. Okay? So we need a 50-degree angle, so that is acute. So that means we're not going to use the numbers up here. We're going to use the numbers down here. So what I do is, because we can't draw a line, right, on top of a compass. A protractor. So I line up the 50 with a straight edge, and then I go from the center of that dot to 50. And then I just draw a little line, so when I move that away, I can come back and draw that line, right? So this connects to there. Yes, I will try to get them posted later. So guys, this week is going to be touch and go for Miss Lavelle because I have a family member that is not doing very well and will probably not be with us much longer. So, touch and go, okay? Yes, drawing these figures are difficult. They are very difficult. So I will try to get videos and posted tonight, but it just depends on what happens. Okay, guys? All right. So this is my angle. And so now I just connect the other 2 points. So the question says, draw 3 circles with each diameter of 1 inch. Can you inscribe each triangle in one of the circles? Okay. Does it have to be that small? No. I could have made a lot larger because I could have drawn a line from there to there, right? And then I could have drawn a 50-degree angle on this end. So I just wanted you to see that there's a variety of ways that we could have drawn this triangle. As long as you had that 50-degree and it touched from end to end. Okay? So that one definitely is a yes. And we can definitely do an infinite amount, as you can see. Alright, so the second one says we're going to draw a triangle with a side lengths of 1.25. Okay? Well, from here to here is 0.5, and from here to here is 0.5, for a total of 1. So is it possible to draw a triangle that has a side length of 1.25? The answer is no. So side length cannot be longer than the diameter. If the diameter is 1, we definitely can't draw something with 1.25. All right, the third constraint is now we're going to draw a triangle with a 30 and a 60-degree angle. Okay, so that means, so remember guys, a triangle has to equal 180, right? So if I have a 60 and a 90, I'm sorry, 60 and a 30, that gives me 90. So that means the third angle has to be 90 degrees. There's no other way, okay? So I am going to use a straight edge to just draw a line. It doesn't matter where you draw it. So I'm going to draw it like this for right now. Okay? And I know that this has to be 90 degrees. So if I put my protractor on the dot, I'm sorry, come on, dismiss. Okay, so 90 degrees would be straight up. So draw that little line and then move it away and then draw that line. Okay, and I don't need to extend it out. It needs to. Okay? So then if you want, it doesn't matter if this is the 30 or this is the 60. Okay? I'm going to make this one be my 60. So once again, line the hole up, line the line up. And it's acute, so that means I'm going to use these up here. So my 60 would be should be something like that. What in the world?
Yeah, it should connect, shouldn't it?
Yeah.
Yeah, that's right.
Yeah, so it should be right there.
Yeah.
It should connect. Okay, so this is 60 and this is 30 and we know this one's 90. Alright, so let me give you just a second to finish copying or drawing or whatever your guys are doing. Now, if you're following along with this lesson and into math, I know they're not having you draw it. So I don't know what they're doing, but I know the interactive lesson, you don't draw it. So what we're going to do is come up with some rules of why things work this way. Okay? So it says, how many triangles can you draw in each of parts A through C? So part A, which was this one, we could definitely draw more than one. Oh, you can't see that, sorry. So part A, more than one. Part B was also more than one. And then, of course, part C, number 1, more than 1. Number 2 was none. And number 3 was more than 1. Okay, so I'll pause there for a second. All right, are we good? Anybody need more time? Okay. Thank you, Hillary, for responding. Oh, you put yes and you put no. All right, I'm confused. All right, so now we're going to move into a quadrilateral. Oh, you meant we are good. Okay. So now we're going to go into a quadrilaterals. So it says we're going to draw a hexagon. So how many sides does a hexagon have? Should have 6 sides, right? And it tells me 1, 2, 3, 4, 5, 6. Okay? So I'm going to skip A and B, and I'm going to write it down here. Because what they want you to do is they want you to start it here, then go to the next step here, and then finish it here. So I'm just going to start it all right here. All right, so the constraints. So it says, with side lengths 2, 3, 4, 5, 6, and 7, the 2 longest sides are perpendicular. So my 6 and 7 are perpendicular. So that means they form a 90-degree angle. So we're going to draw 7 squares here. So 1, 2, let's start here. So 1, 2, 3, 4, 5, 6, 7. And then make sure you label them, okay? And then perpendicular would be 1, 2, 3, 4, 5, 6. Okay. The third longest side is parallel. So the longest side and the third longest side are parallel. So that means this 1, 2, 3, 4, 5. So now this and this are parallel. The longest side versus 5. Okay? So then we have 2, 3, and 4 left. So I'm going to draw okay? So if you look, guys, we can't use inches, right? So if I measure this, this gives me 3 centimeters. So we're going to say 6 units is 3 centimeters. So that means if I have a 4, right? So if I have 4 units, we're going to divide that by 3, and so my line's going to be 1.3 centimeters. So I'm going to probably slant that one, and I'm going to go to that third dot. So there's 1, and then 1, 2, 3. And I'm going to call this one 4 units. All right, and then 3 and 2 doesn't really matter, so I can draw this one 1 centimeter, right? Because 3 divided by 3 is 1. So I'm going to re-slant this one because it's not going to give me enough of what I need. So there's my 3, And then my 2 is going to have to be something like this. Okay? So 7, 6, 5, 4, 3, 2. Does yours have to look specifically like that? No. You may have been able to slant that a little more and get the 3 to come down and then the 2 to come down. It just depends. Okay? So the question says, the figure does or does not have at least one line of symmetry. So if you remember, line of symmetry means that I can take a line, right, and I can cut it this way, and when I fold it, it's going to give me the same image. Or I could cross it this way, and when I fold it, I can get the same image. So neither way, you can see if we fold it this way, it's not right. If I fold it this way, it can't be right because this is a 4 and this is a 2. This is a 7 and this is a 5. So that answer would be does not have one line of symmetry. There's no way. Okay? No way. Remember, line of symmetry is like looking at yourself in the mirror. It's the absolute same, but it's just reversed. All right, so I know we have 2 minutes. So let's try to see if we can get this last one done. So it says, we have 1 minute. All right, Kaylee has a square piece of wood with a side length of 48 inches. She wanted to use it to build the largest circular tabletop that she can. Draw a scale model of the piece of wood. Be sure to include the scale used in your model. Then draw the diagonals to find the center of the circle, which will be the center of the circle, and draw a circle. All right, so what I did is I said 1 inch is going to equal that 48 inches. So I drew. So the first thing I need to do is not that, right? I need to draw my 1 inch square. So 1 inch. One inch, 1 inch, and 1 inch. All right, guys, so we will pick up from here tomorrow, okay? You guys have a great night.